Welcome back to Universe Intelligence, Space Explorers. Today, we're diving deep into the cosmic abyss to uncover the colossal powerhouses of the universe, the largest stars ever observed. These stellar giants are not just massive orbs of gas. They are cosmic forges where elements heavier than iron are created, shaping the galaxies we know. But their immense power comes with a price. We'll explore the dramatic life cycles of these stars, from their fiery births to their explosive deaths. And we'll even contemplate the terrifying consequences if one of these behemoths were to venture too close to our cosmic neighborhood. So fasten your seatbelts as we embark on a journey to understand the awe-inspiring beauty and potential destruction of these stellar titans. A comparison of 5 stars. Have you ever wondered which are the 5 largest stars known as you gaze into the vastness of the cosmos? Let's begin with the first on our list, a true colossal monster, Canis Majoris. Nestled within the celestial hunting grounds of Canis Major, you'll find this colossal star, a truly behemoth among stars. It's located in the constellation of Canis Major and is a red hypergiant of staggering proportions. Here are some of its mind-boggling characteristics. Canis Majoris is one of the largest known stars. Its radius is estimated to be between 1,420 and 1,900 times that of our Sun. Despite its enormous size, Canis Majoris is relatively cool for a star of its type. However, it's still incredibly luminous, shining with the equivalent of tens of thousands of suns. Due to its immense size and mass, Canis Majoris is highly unstable. It loses mass at a rapid rate, creating a vast cloud of gas and dust around itself. This star is classified as a red hypergiant, a type of star that has exhausted much of its core hydrogen fuel and expanded dramatically. If it were to replace our Sun, its atmosphere would extend far beyond the orbit of Saturn, completely engulfing the inner planets. As a result of its rapid evolution, Canis Majoris is nearing the end of its life. It's expected to explode as a supernova in the relatively near future on cosmic timescales. We're going now to delve into the fascinating world of another of the largest known stars in the universe, Scuti. Imagine a star so massive that it would engulf the entire orbit of Jupiter if placed at the center of our solar system. That's Scuti. This star is considered one of the largest known stars. Its radius is estimated to be about 1,700 times that of our Sun. Scuti is a red supergiant star, which means it's one of the largest and most luminous stars known. Its reddish hue is a giveaway that it's relatively cool compared to other stars. Specifically, Scuti has a surface temperature of around 3,600 Kelvin. To put that into perspective, our Sun has a surface temperature of about 5,777 Kelvin. The reason red stars are cooler is due to the radiation they emit. Hotter stars emit more blue light, while cooler stars like Scuti emit more red light. This is because the wavelength of light emitted by a hot object is inversely proportional to its temperature. Red supergiants are in the late stages of their lives. They've exhausted the hydrogen in their core and have expanded enormously. Why is Scuti losing mass? Due to its immense size and low surface gravity, Scuti is constantly shedding material into interstellar space. Its final chapter will be a supernova explosion, leaving behind an expanding nebula. Located in the constellation Cygnus, we have now another monster on our list. Cygni. It's one of the largest and most luminous stars known, situated approximately 5,500 light-years away from Earth. To give you a better idea of its location in the sky, Cygnus is a relatively easy-to-spot constellation in the northern hemisphere, thanks to its distinctive cross shape that resembles a swan in flight. It takes light 5,500 years to travel from Cygni to Earth, so we are seeing the star as it was 5,500 years ago. Why is it so famous? Cygni is one of the largest stars known, with an estimated radius between 1,640 and 2,770 times that of the Sun. It's also one of the most luminous stars, emitting light equivalent to about 270,000 times that of the Sun. It's a red hypergiant, a star that has exhausted the hydrogen in its core and expanded enormously. Cygni is surrounded by a bean-shaped nebula, formed by the material ejected from the star itself. To visualize the exact position of NML Cygni in the sky, I recommend using a planetarium app or a telescope with a good star map. NML Cygni, with its irregular pulsations, is a variable star. Its luminosity varies over time, with a period of about 940 days. If it replaced our Sun, its atmosphere would extend far beyond the orbit of Jupiter, engulfing the inner planets. As a red supergiant, NML Cygni is nearing the end of its life. Eventually, it will explode in a supernova, scattering its material into space and enriching the interstellar medium. All right, science explorers, we've reached the fourth star on our list. Are you ready? Let's introduce you to Westerlund 126e, the only star on this list that isn't a red hypergiant. This true cosmic monster is actually a blue supergiant, and its surface is incredibly hot. While we've already established that Westerlund 126 is a blue supergiant, let's delve a bit deeper into what that means. As a blue star, its surface temperature is estimated to be tens of thousands of Kelvin, making it one of the hottest stars known. This star is not only hot, but also extremely luminous, radiating many times more energy than our Sun. Its luminosity is so high that it ionizes the surrounding gas and dust, creating a nebula. Due to its extreme luminosity and high temperature, Westerlund 126e is a very massive star, but despite its immense size and luminosity, blue supergiants have relatively short lives. Westerlund 126 is likely only a few million years old and will eventually explode as a supernova. As its name suggests, this monster star is located within the Westerlund star cluster, one of the most massive star clusters in our galaxy. This cluster is home to many other massive stars, including other blue supergiants. Why this so different from the other stars we've discussed? Blue supergiants represent a different stage in stellar evolution compared to red supergiants. While red supergiants are nearing the end of their lives, blue stars are still in their prime. These are fusing heavier elements in their cores, such as helium, carbon, and oxygen. This rapid fusion process is what generates their immense heat and luminosity. If it were at the center of our solar system, its atmosphere would probably extend to the orbit of Mars. The fate of Westerlund 126 is likely to be quite dramatic. When it eventually collapses and explodes as a supernova, it will release a tremendous amount of energy and create heavy elements that will enrich the interstellar medium. Okay, explorers, we've reached now the end of our list, and what a way to finish. Meet Stephenson 218, a real cosmic monster. Stephenson 218 is a red hypergiant star located in the Scutum constellation. It's one of the largest known stars, and for a while it held the title of the largest star ever discovered. As a red supergiant, Stephenson 218 has a relatively cool surface temperature. It's estimated to be around 3,200 Kelvin. This star is extremely luminous, radiating thousands of times more energy than our Sun. Stephenson 218 is located within the Stephenson cluster, a region of massive stars and nebulae. With a radius roughly 2,150 times that of our Sun, Stephenson 218 is a colossal star. Imagine placing it at the heart of our solar system. Its atmosphere would swallow up Saturn and Uranus, stretching nearly to the outer limits of our solar system. It's a mind-boggling scale. Like other massive stars nearing the end of their life, Stephenson 218 is very unstable. It loses mass at a high rate due to strong stellar winds. Its ultimate fate is a supernova explosion, which could potentially form a black hole. A deep dive into stellar giants. Imagine plunging into an ocean of fire, where gravity is so intense it bends space-time. That's what it's like inside a giant star. These cosmic behemoths are born from colossal clouds of gas and dust that collapse under their own weight. At their core, nuclear reactions ignite, fusing atoms together and releasing unimaginable amounts of energy. It's through these processes that the heavier elements in the universe are created, the elements that make up planets, stars, and even us. A short but spectacular life. Unlike smaller stars like our Sun, giant stars burn through their nuclear fuel at a breakneck pace. This leads to a shorter but more dramatic end, filled with spectacular events. But ever seen a star that beats like a heart? Many giant stars exhibit regular or irregular pulsations caused by instabilities in their interiors. Picture a giant ball of fire expanding and contracting rhythmically, a fiery demise. When a giant star runs out of nuclear fuel, it undergoes a catastrophic explosion called a supernova. During this explosion, the star releases as much energy as billions of suns in just a second. The material ejected from the supernova is scattered throughout space, enriching the interstellar medium and creating the conditions for the birth of new stars and planets. Shaping the universe, supernovae are like cosmic forges, creating heavy elements like gold, silver, and uranium. These elements are then dispersed throughout the universe and incorporated into new generations of stars and planets. Without supernovae, the universe would be a much poorer place, and we wouldn't be here to tell the tale. A catastrophic encounter when giants collide. Let's imagine a doomsday scenario. One of the giant stars we've been discussing ventures dangerously close to our solar system. What would happen? A deadly embrace. As the giant star approaches, its immense gravity would begin to perturb the orbits of the planets. Neptune, the farthest planet, would be the first to feel this force, being slowly dragged inward towards the solar system. Following Neptune, Uranus, Saturn, and Jupiter would also be destabilized, trapped in a deadly dance around the intruding star. The inner planets, including Earth, would be bombarded by an enormous amount of ultraviolet radiation and X-rays, rendering any form of life impossible. The tides caused by the giant star's gravity would cause devastating earthquakes and volcanic eruptions on a global scale. Finally, our sun would be slowly consumed by the giant star, bringing an end to the existence of our solar system. But what if two of these giant stars collided? The consequences would be even more catastrophic. When two giant stars approach each other, their powerful gravitational forces pull them towards each other at ever-increasing speeds. Upon impact, a colossal explosion would occur, releasing an unimaginable amount of energy. This explosion could trigger a supernova, or even lead to the formation of a black hole. Which of the two stars would prevail? It depends on their masses and their relative velocities at the moment of impact. Generally, the more massive star has a better chance of surviving the collision, incorporating some of the mass of the smaller star. However, it is also possible that both stars would be completely destroyed in the impact, an uncertain future. Fortunately, such events are extremely rare. The distances between stars are enormous, and the chances of two giant stars colliding are very low. However, studying these extreme scenarios helps us better understand the processes that govern the universe and appreciate the fragility of our small planet. Alright, space explorers, that's a wrap for this time around. It's been an awesome and energizing adventure, right? Shall we try now to draw conclusions from this wonderful journey? These 5 stars represent the pinnacle of stellar evolution. Their sizes and luminosities remind us of how small and insignificant our planet is in the vast universe. Imagining these stars in place of our sun allows us to appreciate the cosmic scale and the fragility of our small blue planet. Dear fellow science explorers, our latest adventure has come to an end. However, our journey is far from over. What do you think of these cosmic giants? Leave a comment and share your thoughts. Subscribe to the channel to stay updated on future videos and continue exploring the universe with us.